S. Chand presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
In this video, we will be learning the concepts related to business mathematics, and especially we will be learning the linear programming problems. So, business mathematics is somewhat related to applying mathematical concepts in order to solve the day-to-day business problems. So, we'll see the concept now.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. The topic that we are starting is linear programming, and in that linear programming, we will be doing these two topics. The first one is introduction to the linear programming problems, and second is problem formulation aspect. So first and the foremost thing is, what is linear programming and why it is called as linear programming? As the word suggests, linear means it is related to somewhat decision variables, and those decision variables would be linearly related to the constraints. So here we would be having a problem which requires optimization. That means either we need to maximize or minimize. Let's say if we want to maximize the profits or minimize the time, then we apply this linear programming problems. But it is also subjected to linear inequalities or equalities, and those are known as constraints. Let's say a worker who is performing some operation on the machine, then that worker is available in the factory for, let's say, 8 hours or 9 hours. So that particular time period is the constraint for the industry. So we name it as a constraint. Then it requires this technique basically involves allocation of the resources in an optimal manner so as to get this criteria of optimality. And in order to solve those problems, which are complex problems, and we have specific set of solutions which are known as graphical method in order to solve those problems, or the simplex method to solve the problems which are related to 3 different decision variables. So what are the basic requirements of a linear programming problem? So the first and the foremost requirement is to have an objective function clear in the mind. If you have an objective function, like you want to optimize the cost, or you need to optimize the profit, which is, let's say, you need to maximize the profit or minimize the production cost, then you can definitely apply this linear programming problem. Second is, you should have certain constraints, like the constraint of the worker I have told you, or you have the limited resources, or you have a limited set of availability of the material in the industry. Then you can apply this linear programming problem. You need to have an alternative course of action. Let's say if one solution fails, then you need to have another solution which is ready. And the decision variables that you are taking into account, that should be non-negative. That means if a company wants to produce, let's say, n number of components, so that number of components should be positive, not negative. That means you need to have a non-negative set of constraints, and you need to have a resource which is limited. Then only you can apply this linear programming problem. So without wasting much time, I'll be coming directly to the problem that we want to formulate or we want to solve. So I'm reading that problem. This problem is related to the day-to-day activity which is of a manufacturer, and that manufacturer produces 2 types of models. Let's say model 1 and model 2, M1 and M2 namely. And each model of type M1 requires 4 hours of grinding. That means that model M1 requires 4 hours of grinding and 2 hours of polishing, whereas the model 2, it requires 2 hours of grinding and 5 hours of polishing. So you have to prepare 2 different models, and you are having 2 different machines, which are grinding machines and polishing machines. So both the models are prepared on the grinding machines and the polishing machines. Now you have the limited number of grinders and polishers. So you have 2 grinders and you have 3 polishers. Each grinder work for 40 hours a week, and each polisher work for 60 hours a week. And there is a profit statement also mentioned. That means the industry is making profit on M1 component as rupees 3, and the company is making a profit on M2 model as rupees 4. So we have to take, we are given with an assumption that whatever is being produced, that is sold in the market. So how this manufacturer allocate the production capacity, that means how many products are to be produced so as to attain maximum profits in that particular week. So first of all, we need to understand that whether it is a linear programming problem or not. So here we have an objective function which is clear in our minds that profit needs to be maximized. And we have certain constrained equations that we are only concerned with grinding machines and polishing machines, and we have limited set of machines available to us. And we also have the availability of the grinders and polishers. We have 40 hours a week for a grinder and 60 hours a week for a polisher. So let's start this question. Initially, what has been given to you, initially they're saying that you have two models, M1 and M2. So we have to find out how many number of components are to be produced. So let's say X1 and X2 components are to be produced. So X1 and X2 are the number of units that are to be produced. And firstly, we have to get an information or define an objective function which is of the maximization type. So here you are given with the values, which is the profit values, rupees 3 and rupees 4. So Z, which is the objective function, it should be of maximization type and it should be 3x1 plus 4x2. So this is the case of the objective function that we have. And now the question says that you have 2 grinders and 3 polishers. So 40 hours a week is available. So total hours for grinding is 80 hours. M1 requires 4 hours of grinding and M2 requires 2 hours of grinding also. So for the grinding, we have the total availability, which is 4x1, which is this 4 times this x1 component and 2 times the x2 component, and that should be less than equal to 80 because the maximum availability is 80 hours. So we have taken the constraint which is less than type constraint, not the more than type constraint. Why? Because this is the maximum availability. Beyond that, the grinder is not available. Similarly, for the polishers, we have 3 polishers available and it was available for 60 hours a week. So it would be 180 hours. That means the constraint that I will be having is 180, and it is mentioned that M1 requires 2 hours of polishing and M2 requires 5 hours of polishing. So for the polishing, I have one constraint equation, which is 2x1 plus 5x2 is less than equal to 180. So you know, I have this equation, which is the final equation. I have this objective function, which is a maximization type objective function, and 2 constraint equation, which are having the less than type inequalities. Apart from that, I need to also write it like this, that x1 should be more than equal to 2 and x2 should be more than equal to 0. So why 0? Because in the starting I have told you that the decision variable should be non-negative. The number of components that the company produces should be non-negative. That means it should be more than or equal to 0. So this is as far as the problem formulation for the linear programming is concerned. In order to solve those problems, we have set methods, which are graphical method and the simplex method that would be seeing in the upcoming slides. But before going to those methods, let's have another look at another problem, which is the product allocation problem. Here the problem is similar, but only the components or the machine requirement is different. So here you have 3 machines, M1, M2 and M3, which produces these 3 products, and the processing time of these 3 machines for first part, for the second, for the third is mentioned. And here also first, second and third, first, second and third. If let's say the first part is to be produced, then for it requires 2 hours on machine 1, it requires 3 hours on machine 1, it requires 2 hours on machine 1 only. And the total availability of the machine capacity is mentioned, 440, 470 and 430. What you need to do, you are given with the profit values for the first, second and third case. So rupees 4, rupees 3 and rupees 6 is mentioned. So what I need to do, I need to apply the business mathematics, which is the linear programming problem, in order to optimize it. So what is done to optimize this problem? I need to increase or I need to maximize those profit values. So in order to get these values, I need to define an objective function. So Firstly, I need to assume that X1, X2 and X3 are the number of components which are to be manufactured in that particular firm, and I need to define that these all decision variables should be non-negative. That means it is greater than or equal to 0. So the step is to define the objective function, as I have been given with the different values for the profits of the components. So I need to multiply those profit values and add them. I need to define this as an objective function. Now I have these constraint equations which are mentioned in the question. That means 2x1 plus 3x2 plus 2x3, it should be less than or equal to 440 for the total time availability. Why less than type constraint is used? Because the maximum utilization of the machine is for the 440 hours. Beyond that, the machine will not work. For less than 440 hours, it is available. So these are the constraints that I'll be having. So in total, I have this objective function and I need to have this constraint equations. Apart from that, these constraint equation, I need to define the decision variables as non-negative values. Then you would be amazed to know that this linear programming problem is also applicable to the advertising and media agencies. Let's say I have this problem in which an advertising company wishes to plan an advertising strategy in 3 different media, which is television, radio and magazines. So they have some data like cost of an advertising unit is given for TV, it's mentioned for radio, for magazine 1 and magazine 2. And they're also saying that the number of potential customers or the reach of that particular advertising agency is 2 lakh, 6 lakh, 1,50,000 or 1 lakh. For the magazine 2 values, and the number of potential female customers that the agency is targeting is 1,50,000, 4 lakh, 70,000 or 50,000. And the company has certain obligations. The company wants to spend not more than 4,50,000 rupees on the advertising values. And the customer is saying that I want to have at least 1 million exposures on the female customers. And also they are saying that advertising on the magazine should be limited to rupees 1,50,000. This is the budget of the client that is requiring the advertising from that media agency. And then they are saying that at least 3 advertising units should be brought for the magazine 1 and 2 should be brought for magazine 2. And the number of advertising units for the TV and radio should be 5 and 10. And what you need to formulate? You need to formulate a linear programming problem. So basically you need to understand that what is the basic problem of that advertising agency, or what is the basic problem of that client. So client wants to have the maximum potential reach of the customers and they have certain constraints in their mind. So initially we have an objective function in our mind which is to maximize the number of potential customer reach, and we have certain constraints. So we are pretty much sure that we will be applying linear programming problem to it. And we need to formulate these statements in the form of equations. So how can we do that? Initially, we need to have an objective function which is related to your total number of potential customer reach. So from the table or the information given, you have the number of potential customer reach as 2 lakh, 6 lakh, 1,50,000 or 1 lakh. So we need to assume that the number of components for TV, for radio, for magazine 1 and 2 are mentioned. So I need to multiply these values and add them up and put it equals to Z, which is the maximization part, and I need to maximize it. Second is the constraint that is there on the budget. So the company wants to spend not more than 4,50,000. That means their budget is not above 4,50,000. So we need to look for the budget which is available. So they are mentioning the cost of advertising unit for the TV, radio, magazine and magazine 1 and magazine 2. So you need to multiply all these budget values with the components, add them up and put it equals to or less than equal to 4,50,000, which is your first constraint available. Then the company wants to target the female customers. So they are mentioning that the number of female customers exposures should be 1 million, at least 1 million. That means at least 1 million should have a constraint of more than equal to type. That means the minimum number that they are targeting is 1 million. So we need to have more than 1 million values. So they are given the previous or the past data about their advertising agency, which is the number of female customer reached, which is 1,50,000, 4 lakh, 70,000, 50,000. So multiply all these values with the decision variables and put it equals to more than equal to 1 million, and expense that they want to spend on the magazine. So magazine 1 expense was 15,000 and for the second is 10,000. It should be less than equal to 1,50,000. And the number of advertising units for magazines and TV. They are saying that for the first it should not be more than 3, and for the second magazine it should be more than 2. So more than equal to 3 or more than equal to 2, and the number of TV or the radio sets are between 5 and 10. So x1 is less than equal to 5. It lies between 5 and 10, and this also lies between 5 and 10. So this is basically the problem formulation part. That means your expectations are converted into a mathematical model. Then what we want to have from this mathematical model, we want to derive a particular solution. So in order to have a particular solution about these values, we need to solve it either by any of the methods, which is graphical method, or it can be a simplex method. So graphical method is basically applicable to 2 decision variables, and if you have more than 2 decision variables, you can go for the simplex method. We stop here for a short break, and after coming from the break, we will learn about some more problems which are related to the linear programming problems.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back after the break. Before going to the break, we were doing the linear programming problems, and in those linear programming problems, we have seen the aspects of business related problems in which this LPP is applicable. Now, I wanted to start with another set of equations in which I have taken certain examples of a dietitian. Like dietitian wants to give a particular set of complementary diet to a particular patient, or let's say a person who wants to, who is doing gym. So for that particular person, this dietitian or the diet problem is very much popular. So we'll be understanding that with the help of this linear programming problem. So I'm straight away coming to the problem or the example. So this is the example of that diet of a person. So a person wants to decide the constituent of a diet which will fulfill his daily requirements of proteins, fats and carbohydrates. So that person wants to have this fulfillment in minimum cost. So the major problem of a person who is doing gym is the cost value. So that person do not want to spend more on these dietary requirements, but he wants to cover up, or he wants to complete that dietary requirements in minimal cost. So what he can do, he can use those food types. Let's say I have 4 food types or 4 different food boxes or the supplements that I want to use in my diet. So these food items are basically having written the yields of different requirements that is to be fulfilled. Like yield per unit is mentioned for the first food type as 3. For the first food type, fat is mentioned and carbohydrate is mentioned, and also its cost is mentioned, 45. And for the second food item similarly, and for the third food item, for the fourth food item is mentioned. And the minimum requirement of the person is also mentioned, like the person wants 800 calories of this proteins and 200 for the fats and remaining for the carbohydrates. And we need to formulate the linear programming model. So firstly, we want to understand that whether it is a linear programming problem or not. Here we have a set objective function in our mind, which is the cost minimization. The person do not want to spend more on the cost value, but he wants to have the dietary requirement fulfilled. Apart from fulfilling the dietary requirement, he has certain constraint values. So these are those constraint values that we want to understand. So here the cost was mentioned about the different food items. Let's say if I want to purchase x1 units of food item number 1, x2 units of food item number 2, x3 for food item number 3 and x4 for food item number 4. So I need to multiply all these with the cost per unit and I'll get that function z. That needs to be minimized because I need to minimize the cost. I don't want to spend more on the cost. Then there are certain dietary requirements for fats, for proteins and carbohydrates, and that minimum requirement is mentioned in the data is 800, 200 and 700. The minimum is mentioned. That means the constraint that we'll be using here is more than type constraint, not the less than type constraint that we have seen in the previous examples. Why more than type constraint? Because this is the minimum requirement. If a client is getting, or if a person is getting more than this value, then he is more than happy. So for that, I need to multiply all these component values and sum them up and put it more than equals to 800. And for the similar equation for fats and carbohydrates, we can have these constraint values equations. Apart from those constraint values equation, we need to write that x1, x2, x3 and x4 should be more than equal to 0. So we need to mention additionally that x1, x2, x3 and x4, they all should be more than equal to 0. That means they are non-negative as explained in the initial part of the lecture. Then I have another example which is related to the paper production, or you can say an example of a paper mill, and that paper mill is basically producing rolls of the paper which is used for the cash registers, and they are using a roll which is 100 meter in length. So you have a big roll which is 100 meter in length, and the company wants to produce different width of the paper, let's say 2 centimeter, 4 centimeter, 6 centimeter and 10 centimeter, and the company's production process is results in the roll that are 24 centimeter in width. So you have a particular value of the width, and from that width you want to cut down it into different widths of the paper. So they are mentioning that you have 6 different cutting alternatives. So let's say if I have these alternatives, so cutting alternative 1 will produce 6 units of, let's say this 2 centimeter width, and for 4 centimeter width they are mentioning, for 6 centimeter they will not produce, and for 10 centimeter they will not produce, and apart from that wastages are also mentioned. So you know that whenever you cut something there must be some wastages. So wastages they are mentioning, which is the data that the company has, and what is basic requirement of the company. The company wants to have the maximum demand of, the company has a demand forecasting for these values of rolls. Let's say for 2 centimeter width paper the demand is 2000, and for this, for 4 centimeter width of paper the demand is 3600, similarly for 6 centimeter and for the 10 centimeter, and we want to formulate this linear programming problem. So what is the major issue or major concern of the company here? Not related to cost, not related to anything, because the cost values or the profit values are not mentioned in this particular set of problem. So what is mentioned, they are mentioning about the wastages, and we are pretty much concerned about the wastage which is being produced by different cutting alternatives. So we need to minimize those wastages depending upon your constraint or the decision variables. So initially you have 6 different alternatives. So x1, x2, x3, x4, x5 and x6 are the different you can say cutting alternatives. So what you want to use, you are representing them as a number of times each cutting alternative is used. Let's say x1 represent the cutting alternative 1. So you have an objective function which is related to your wastages. So minimize type objective function should be there. And if you have the number of wastage values, let's say you don't have a wastage here. So 0 into x1 plus 0 into x2 plus 2 into x3 plus 2 into x4 plus 2 into x5 and 2 into x6. So all the 2 values are common. So we'll start this objective function from x2 values, x2, x3, x4, x5 and so on. And you have the constraint equations in your mind for the set of, let's say this, which is the first cutting alternative. You have 6 into x1 plus 1 into x3 plus 4 into x4 and so on. You have a constraint which is there mentioned in the question. So you have the demand for the first cutting alternative, or you have the demand for the first width of the paper, which is 2 centimeter. So for all these you need to total them up and you need to put, or take the right hand side as 2000, but it is mentioned the demand. So demand is the minimum requirement of the client or the company. So for having the minimum requirement, this value can exceed. So it can be more than or equal to 2000. And similarly for the next set of constraint for 6 centimeter, for 10 centimeter, you need to put in all these values. So what you have done from all these expressions, you have the target of the company, or you have the requirement of the company. You are converting that requirement into a mathematical model, and basically your idea is to get a particular solution for that company. So with this, we come to an end of the lecture, which is based on Introduction to Linear Programming and Problem Formulations. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.